Alright, so now let's look at tables of periodic functions and see how they work. By the end of this, you should be able to identify whether a function is periodic from its table or if it is not periodic. So looking at this first table here, we've got the values for x, -4 through 4, all with a step of 1 in between them. And then on the y-axis, let's follow this pattern. We go -1, 0, 1, 0, -1, 0, 1, 0, -1. And so I think that your hunch might be telling you, just like it is for me, this is periodic because I can see that there is this clear period in here. We go from -1, 0, 1, 0, back to -1 where it begins again. So what is the length in between this? How do we determine what the period is? Well, let's start here, right above the -1. And then it looks like we get back to -1 here. And we can actually space out the next period right here as well. It looks like the period is a length of 4. There's 4 digits in between here. We go from -4 to -3, -2, -1, and 0. What is the distance between 0 and -4? Well, it's a space of 4. So our period in the first one is 4. All right. Now in the next one, let's go ahead and see what x values we have here. They all look like they have a step of 1 in between them from 0 to 9. And now for our y, let's look at those individually. 1/2, 4, 1/2, -3, 1/2, 4, 1/2, -3, 1/2, 4. So again, we have a periodic function. There is a function in here that goes from 1/2 at the beginning up to 4, back to 1/2 again, down to -3, and then back up to where it started. So I can draw in right there to the table and space out between each of my periods. I wouldn't want to draw anything like I'm doing right here. I wouldn't want to space out in between every single 1/2 because this 1/2 goes to 4 first, and then back down to 1/2, and then to -3. We have to include both of those, so don't put it like that. Okay, again, it looks like our period is 4 here because we go 1, 2, 3, and 4 steps in between. So our period is 4. Next one. All right, this time we're going to be talking about it in terms of pi. So here we go, start from 0, and then it has a step of pi over 2 each time. So if we go from pi over 2 to pi, this is just adding another pi over 2. From pi to 3 pi over 2, that is just adding another pi over 2. From 3 pi over 2 to 2 pi, again, that is just adding another pi over 2. That's just fractions. So if you go from pi over 2 and you add 3 pi over 2, how many halves of pi do you have? You got 3 here, you got 1 here, that is 4 halves, or other words, 2 pi. That's how that works. So now let's go and look at the y values. We have 1 at the beginning, then we go to radical 2 over 2, then down to 0, then negative radical 2 over 2, and then -1. Negative radical 2 over 2, again 0, then positive radical 2 over 2, and then back to 1. So it looks like this is periodic, because then it goes back down to radical 2 over 2 again. So from here all the way down to here, this is a single period, and then it begins a new one right here at this 1. So how spaced out is that? Well, let's put in some barriers so that we can focus in on just this area. So that's the amount of time it takes to get from one period to the next. We went from 0 all the way to 4 pi. And so it looks like our period length is going to be 4 pi. So that's kind of a longer one. If you wanted to think about this in terms of the normal number system, you can multiply 4 times pi, which will get you 12.5 or 6-ish. Something about that. That's the length of pi there. But let's always try to be as accurate as we can by using the exact number for pi. Here are some non-examples now. What are some examples of tables that are not periodic? Well, let's look at this first one. Again, this is spaced out on the x-axis exactly like the last one. We are just going to increase by pi over 2 every single time from 0 all the way out to 9 pi over 2. And then on our y, we go from 0 to 1, so we go up, down, back up, down, down again, up to 0, up, down, and then kind of up to a half. There's not a pattern that I see in here. It kind of looks like at the very beginning it was going to do something periodic because it went 0, 1, 0, 1, but then after that it broke the pattern. So there's no periodicity here, and so it's not a periodic function. If I had to reference my table to explain why, I would say something like it had a pattern of 0 to 1 from there to there, but then after that it broke the pattern and went back down to negative and then back up to positive, but not in the same amount of time that it did before. Alright, x and y, here's our next one. We have, this time we're not talking about pi anymore, we're just talking about a step of 1 in between each one of these, so negative 2 to negative 1, 0, 1, 2, 3, and all the way to 6. On the y, we have 5, 4, 5, 6, 7, 5, 4, 5, 4. So it looks like it almost was similar between this spot and this spot, but it wasn't quite the same. 5, 4, 5, 6, 5, 4, 5, 4. And even if that was the case, we still have this 7 in here, which I'm not sure how that would have been represented. So there's no periodicity here. It is not periodic. Not quite the same pattern. So hopefully now you've got some taste for how you can determine whether a function is periodic or not using its table. Go ahead and check out the further videos and also the week 7 practice.